Hello everybody, thank you for joining us today. I'll just introduce my colleague Seamus Rooney in 1 second, but I'm Lindsay Teal and I'll be today's host for the webinar, which should last around 45 minutes. So we're joined today by Seamus Rooney, and Seamus is one of our renewable heat specialists and has worked with organisations across Scotland to help them design and install renewable heat solutions. So from heat pumps to solar, thermal, and of course today's topic, biomass. Now, if during the session you want to ask any questions, you'll see on screen there the questions panel. So at any point during today's session, just enter your question and it will come to me, and we'll stop at a couple of points throughout today's session to put those questions to Seamus. And if we've got any questions we don't get a chance to answer, then we'll do so, we'll follow up with you after today's webinar. If you use Twitter and you enjoy tweeting, then we also encourage you to use the ResWebinar hashtag so we can track all the tweets that are coming in. And if you want to tweet your questions rather than use the questions panel, then I'll pick those up as well. So that's it. I'll hand you over to Seamus, who will start today's webinar.
Hello everyone. Today we're going to talk through our top 10 10-step process to follow to carry out a successful biomass project. We're going to go through the steps themselves, and then afterwards we're going to go through some key problems to avoid, and once you're up and running with the biomass system, how you can run it so that it will be successful. So the 10 steps we're going to cover today, you can see on screen now. The first few steps are preparing yourself for discussions with suppliers, so that when you speak to suppliers you're informed and you've got the information that they need. It means that you can get the best out of your engagement with them. Then I'm going to talk you through step 4, once you're speaking to the suppliers and once you start to review quotations and you're speaking to a few people. And then finally, later on, steps 6 to 10 are once you've decided what you're wanting, you know exactly how you're going to go about getting it. It's following through the process to make sure that what you get is what you want. So we're going to start off now with a poll, and I'll hand you over to Lindsay.
Yeah, so we just really want to understand, as we're starting, what kind of stage everybody joining us today is at. So I'll just launch the poll and it should be coming on screen now. So really, what stage in your biomass journey are you at? Are you just investigating the options? Are you now at the development of a specification? Are you already looking for suppliers, or are you looking to run an existing system better? And so if you could just start completing that poll on now, then it will give us a kind of steer on what stage everybody's at. So a bit of a mix. At the moment, most people online are just investigating, with a few developing a specification and a few looking for suppliers. But nobody is looking to run an existing system better, so most people are obviously at that kind of initial biomass stage.
It's quite interesting.
Yeah.
Hopefully today's webinar will be helpful to steer you in the right direction.
Yeah, I think it'll be perfect for you to kind of get going. So I'll just share the results with you on screen. So it's 83% are just investigating, 8% developing a specification, and 8% looking for suppliers. So that's it. I'll hand you back over to Seamus.
Thank you very much. So our first step in the process is really key. It's understand what your requirements are. So that biomass systems are providing heat, and so key to that is understanding about your heating requirements. How much heat do you use? How do you use the heat? And how is the heat distributed? So the first part of that is how much heat you use. And what you want to find out is a sense of how much heat you use over a year. Now, that'll be in kilowatt hours. Ideally, if you've got heat meters, it can be measured directly, but they are pretty rare. Most people won't be in the situation of being able to meter their heat and know exactly what their consumption is. So in that case, you can find out how much fuel you use, either from your existing bills or from delivery notes from suppliers. So electricity and natural gas will state how much energy in kilowatt hours you have consumed, and that's excellent. You can gather that information, ideally for a full year, because if you've got 1 full year's information, then it takes out any seasonal variations you've got, and it means that they can get as accurate a picture as possible. The longer you've got data for, the better informed your supplier will be, and the more likely it is you get the system you need. If it's not electricity or natural gas, so if you're using LPG or if you're using oil, it's most likely the volume of fuel you've used. So you'll have to convert that into kilowatt hours, either yourselves or if you're doing some of the calculations yourselves, or if it's your suppliers doing that, they'll do it for you. The DEFRA website has information on it about the energy content of different fuels, and so that's the best source of information. Now, when you're measuring fuel, that's the energy going into the boiler. It's not actually how much is coming out as heat, because the boiler will be somewhere between 50% and 80% efficient over a whole season. It may well be more than that, and boiler manufacturers can state in excess of 90% efficiency. But over a whole, what's important here is over a whole heating season, so during times so there's relatively little load through to times when, in the depths of winter, when the boiler's working very hard, how's the efficiency average out? And so it does mean if you've got a very old boiler, your heat demand might be quite a lot lower than it appears from the fuel consumption. And it's something that it's not investigations you need to make yourself. Those kind of things, working out the efficiency would be done by the installer. But having a sense, first of all, having all the information ready for them, so the energy consumption, your bills, and having a sense yourself of what your energy consumption is very useful. The other reason it's important is because it will impact on how much renewable heat incentive you get, and it will be used in your own internal calculations of the business case. So it's really important that that is known, and is known as accurately as possible in total heat consumption for the year. So moving on to peak heat loss. This is the maximum rate you use heat, and this is what's used to decide how big a boiler you need. And the peak heat loss will be different for the different heat consuming systems you've got on site. So if you've got space heating, if you use hot water, or if you use process heating, then each of those will have their own peak requirement. And the peak requirement of the whole system will be those systems which operate at the same time. So it might be, for example, if you've got process heating which is running 24 hours a day, and you've got space heating only on during the day, and you hot water on at night, it won't necessarily be all of those added together. What's key here is understanding what information your supplier is likely to need from you so that they can work it out. It's not something that you're likely to have to work out yourselves unless you're getting deeply involved in the sizing of the system. So for space heating, for example, we need to think of how big a building is it, what age of construction. We want to know as much information as possible about the fabric of the building so that they can calculate accurately what the requirements are. For hot water, it's how much hot water you use, and also its pattern of usage. So if your business is a cafe, for example, does it you use it only for hand washing, or do your dishwashing equipment use hot water, or is it electrically heated? So if you can gather as much information on these as possible, then it, again, minimises the amount of estimation your supplier will have to do, and will help you get a more accurate idea of the correct system from the start, and will hopefully assist you in getting the right system when you finally go to purchase it. I'd reiterate, it's the responsibility of the installer to size the system for you. But if you inform them correctly, then it helps them do their job. So moving on to boiler sizing, it's important to note here that it's not always the case that a biomass boiler would be sized to meet the peak load. It's important that your heating system overall, so the biomass boiler and any other heat sources, are able to fully provide for your needs. But if a biomass boiler is oversized, it tends to be inefficient. And this is a result of biomass boilers reacting relatively slowly to load, and also they are limited in the extent to which they can ramp up and down their output. And so sizing of biomass boilers needs some care, and usually it's done in combination with some buffer tanks with thermal stores to spread out the load. Or it can be that one or more biomass boilers are used together, or indeed another heat source, so perhaps an existing oil or gas boiler as a backup with a relatively small biomass boiler for base load. Now, as a consumer, this is important because if you're looking at different installers and you're getting very different numbers back in terms of the boiler requirement, having an understanding of the way that biomass boilers can be used to best efficiency and to make sure they're reliable will help you make sure that you can pick which supplier is the one that's most likely to give you the system that's going to work well for you. And so we're going to move on now to another poll, so I'll hand you over to Lindsay.
Yeah, so we're interested to know currently what heat source you use. So coming on screen now, you'll see the options that we've got there are natural gas, LPG or oil, electricity or other. So if you could just take a couple of moments to complete that, that'll help give Seamus a steer on kind of where people are at right now. So natural gas is kind of in the lead at the moment at 71%.
That's quite interesting, and there's also quite a number of people using electricity as their main heat source.
Mm-hmm. So I'll close that now. I think most people have taken the time to complete that, and I'll share the results with you. So 73% natural gas, 9% LPG or oil, 18% electricity, and 0% using any other heat source.
What's interesting about that is that the different fuels that people use has a real impact on the financial, the payback of a system and how much you can save. And the 18% of people who are on electricity are most likely to be able to make very significant savings. With natural gas systems, that can be a bit more of a challenge to make the systems pay, and it's really important to get the sizing of the system right and make sure the calculations are, your business case is robust, to make sure that you really accurately understand what the savings is going to be.
Fantastic. So I'll take those down and I'll hand the slides back over to Seamus.
So the next thing, just continuing on with information about your system. It's really important that you understand how the heat's distributed. So the existing system that the biomass boiler is going to connect to. Most systems are low temperature hot water. So this is water up to around 100 degrees. And if no information is available, it's very likely that the installer will make the assumption that that's the system you've got. So it's really important that if you use medium temperature or high temperature hot water, which operate at much higher pressures, or if you use steam, that you make that very clear from the outset, because the equipment you need is likely to be different. And businesses which process heat, for example, quite often uses steam or high temperature hot water, or even other mediums such as oil. If you're operating in a factory, they tend to be very different from what the types of systems it would be doing space heating and domestic hot water in a building. So moving on, getting away from the technological requirements, it's really important you understand what your own financial requirements are as well. What is it you're trying to get out of it? How much money do you have to spend? What's your access to capital? And what return do your business require? Is it the case, for example, that a system which is going to be more capital intensive but offers a better financial return something that you would consider? Or is it really important, is the cost of the system initially the most important? Understanding those things will help steer you towards the right system. There's a lot of different types of biomass systems out there and they perform very differently. So once you understand what you've got and what your financial requirements are, the next step is to try and find out what's actually technically possible on your site. And so when your installer is making an assessment of this, it's going to be specific to the types of fuels that they're considering. Many suppliers will do more than one type of biomass boilers, but some specialise. So it's important that you have an understanding of the different types of biomass and which of them might be suitable for you. So just quickly, wood pellets are the most manufactured of the wood fuels. By that I mean they're a regular size, They are pellets of usually between 6 and 8 millimetres. They are dried to a preset moisture content. They're produced in a factory, and because of that they are easy to handle through automated equipment. They can be delivered automatically into fuel stores, and they tend to result in systems which operate efficiently and reliably without a significant amount of intervention. Biomass boilers will always need some more intervention for cleaning out ash removal and that kind of thing compared to oil and gas, but of the fuels, the wood pellets are the least work day to day. But the downside of that is the fuel is more expensive. So wood chip is quite often attractive for people who use a significant amount of heat because the cost of the fuel is less. The downside of wood chip is that the cost of the equipment that you require is likely to be much more. Fuel handling is not as easy. The mechanism, part of that is because the wood pellets will fall naturally to the bottom of a wood store, whereas wood chip won't. It sounds like a bit of a technical point, but it really fundamentally affects how the mechanisms that you need. Wood chip can form bridges and can form caverns, and so it needs a lot more equipment to move it around, and that's a lot of money. It also takes up more space. So wood chip systems can be an excellent option for sites which use a lot of heat, and it's worth them investing more money at the outset to save money on the operating costs later on. The other issue potentially with wood chip is that the moisture content tends to be a lot higher, and you tend to encounter more operating problems than you would do with wood pellets. It's less uniform, both in terms of the size of the pellets and in terms of the moisture content, and both they can affect either the boiler itself or the fuel delivery system. Either way, it could have an impact on your business if it turns off. Log boilers are very different from wood chip and pellet boilers on the whole. They tend to be manual systems. They're manually fed. They require intervention usually once or twice per day, where pellet or chip systems may operate for a week or more without anyone having to go to the boiler. And they are most suited to the likes of agricultural sites where there are people who are able to clean out the boiler, feed the boiler manually. And so they don't tend to be suited to the likes of office environments. So when making an assessment of the suitability of your site, one of the most important things is whether you've got space for the plant. Biomass boilers, buffer tanks, biomass fuel stores all take up significantly more space than oil or gas systems. And so having somewhere to store fuel, having somewhere to locate the equipment is going to be very key, but it's also important you can get things onto site. So access, whether that's the width of access roads, whether that is the access directly to the fuel store. So it's important that a fuel delivery lorry can get up to where you're going to be storing the fuel. Also, it's worth considering from your business perspective what the impact, how much labour, how much time it would be possible to spend operating the boiler. So for a system which needs more manual intervention but it's much lower running costs or much lower capital costs, for example, is that something you would think of, or can that be ruled out at an early stage? Does it need to be something that operates automatically? Understand, it's important you make those decisions yourself so that you can communicate them to the supplier. It also might impact on whether you decide to use a maintenance contractor to do some of the work for you. The limitations, one of the limitations potentially on where you can locate biomass boilers is air quality management areas. These can be found on your local council website, and these will place a restriction on the design of the system, and really they can prevent biomass systems going ahead because it can become unaffordable to install the flue gas treatment that's required to comply with the air quality management area restrictions. The planning restrictions affect some sites more than others. And so it's worth thinking about. This can also be for listed buildings, for example. So if you are in a situation where you're likely to need a very tall flue, and you are placing it somewhere that has very restrictive planning environment, it's worth being aware of that, considering it, and having conversations with your planning department at an early stage, because it's important both to make sure that you, if it's possible to go ahead with a system, that you're aware of what you're going to have to consider, whether that's aesthetically or design of systems, to make sure you comply with that. But also, if there's something which is going to clearly prevent you going ahead, it's not worth investing a lot of time in getting to a much later stage only to discover that something you could have known at the beginning which prevents you going ahead. And finally, just a little point specifically, if you've got a site with changes in level, it's worth identifying that with your supplier, because one of the major costs with wood chip is the delivery, the mechanisms to receive a delivery of wood chip, and they can be tipped from a tipper lorry. If you happen to be lucky enough to have a site where you've got an access road and somewhere you can place a plant room adjacent at a lower level, they're ideal for wood chip. So moving on, step 3. It's important that you can source fuel which is affordable and which is of a sufficiently reliable quality that you're going to be able to operate the system for its lifetime. And so for the type of system that you're considering, if you have made a decision early on, or if you're still very open-minded about what you want, it's worth finding out what fuel is available in your area. So fuel suppliers, for pellets, they may be more national suppliers, and it might be an issue of what's the cost of getting it delivered to your site if you're in a very remote location. But finding out all of the suppliers, what fuels they can supply, again, what delivery vehicles they need to use. If they have a articulated lorry, certain suppliers only do very large deliveries using very large delivery vehicles. Are they going to be able to get to your site? And if you have you find that you're restricted to a small number of suppliers and an individual supplier, it's worth considering whether they're going to be around for, say, 20 years that you're operating the system for, or if you're going to be exposed to significant fluctuations in fuel price, which might affect your business case. Finally, as I mentioned before, some suppliers only do large deliveries, but many of them will offer you a discount for large volumes. So if you're doing 10 tonnes or more, then some pellet suppliers will give you a discount. It's worth being aware of that at an early stage, because it may be that installing a slightly larger fuel store doesn't add a lot of cost if you've got the space to do it, but could save you quite a bit of money for operating the system later on. So, we're going to, Lindsay, we're going to look at some questions now. Have we got some come in?
Yeah, we've got a couple of questions that have come in, but yeah, if you've got any that you want to ask, then just pop them in the question box that you'll see on, it should be on the right hand side of your screen if you've got any questions. So the first question we've got is, someone's asking, can I start out burning wood pellets and then swap to burning wood chip at a later date?
It's a good question. It can be possible, but the fuel handling equipment is different for wood chip boilers than it is for pellet boilers. And so if you have a system which burns wood chip, it's more likely that it's able to burn pellets. If you buy a system which is designed for pellets, you are more than likely not going to be able to burn wood chip. So it's something you need to decide when specifying the system. So if you get the right equipment from the outset, then it gives you that option later on, but it's likely to add some cost to the system. It's worth thinking about, again, if looking at fuel suppliers, if you know that there are wood chip suppliers locally and you can get wood chip affordably, there's quite a lot of people who start off on wood pellets until they've got the system up and running reliably and get past any teething problems, and then swap into wood chip. But you need to think about it early.
Right, okay, perfect. The next question we've got is that somebody has access to their own wood supply, but they're wondering whether or not they can still claim the RHI, the Renewable Heat Incentive, if they burn this.
Yes, you can supply your own fuel. There's some restrictions in terms of if you're processing fuel, for example, but if you're sourcing fuel, it tends to have an impact on what type of system you'll look at, but it's certainly you're eligible to claim the RHI. It's worth looking into the fuel supply, the sustainability requirements which are coming into effect in autumn this year, autumn 2015. As a self-supplier, you'll have some requirements placed upon you for record keeping and that type of thing. But also, if you're self-supplying fuel, it's worth thinking about what type of fuel you're going to be. So if you get wood logs, for example, are you thinking about a log boiler, or are you going to get someone to chip it for you and have a wood chip boiler? It's worth having a bit of thought of the storage and handling implications of supplying your own fuel, because if you're looking at wood pellet or wood chip, it might be, certainly with wood pellets, you're not going to be able to convert the wood into wood pellets. It may be that you can get it chipped and dried, but it needs a bit more thought. But certainly log boilers, it tends to be much easier.
Okay. Hopefully we've got time for another 2 questions. The next one is, what is the typical asset life of a system?
Well, a reference point for this is that the RHI is payable for 20 years. And so if you're installing a system with the objective of claiming RHI, then you're looking for a system that's going to last for 20 years. Now, there are, in that time, you're going to have to do obviously a significant amount of maintenance, but also some plant replacement as well. And so the fuel delivery augers, the pumps, those type of things are likely to need replaced, but you would want the biomass boiler itself to need to be able to last for at least 20 years. It comes down to maintenance as well. If you've got a system which is fueled with good quality fuel, and by that I mean moisture content primarily, which matches the manufacturer's requirements, and it's regularly cleaned and maintained, then you're likely to get a very good lifespan out of it. If the system is not properly cleaned and isn't maintained frequently, then the life can be significantly reduced. One of the things we're going to talk about a bit later on is there are some implications of running a boiler at very small load, and that can significantly reduce the life of the boiler itself. And I think there's some points we can possibly pick up on after the webinar. But if you run a boiler at very low load, it is likely to reduce its lifespan, because you can cause corrosion inside the boiler if it's not coming fully up to temperature and operating at temperature. So it really does come down to how you operate the boiler. The best of boiler systems will fail after a relatively short space of time if they're badly maintained and aren't operated correctly.
This is actually a question from me, but building on Rachel's question, is there somewhere you can go to see the ratings for boilers, or the quality of them?
It's a good question. There's not, as far as I'm aware, the quality rating. The manufacturers will have, for smaller systems below 45 kilowatts, they have to be part of the microgeneration certification scheme, and there's some checks they have to go through as part of that process. And so the installers which have become certified are on that. There's also the energy technology list where you can look for suppliers, but they tend to be about the performance of the boilers rather than their quality and longevity. Although biomass boilers have been running in this country obviously for a long time, but the uptake has increased significantly since the start of the RHI in 2009. So there's some experience out there. You can look to other people, but Austria, Switzerland, Germany have had high uptake of biomass for much longer than us, and so there is case studies and examples online. You can find out what suppliers get good feedback, and it's worth speaking to other people to find out their experience of biomass boilers.
Yeah, I was thinking the Green Network for Business might be a good resource for that as well.
Absolutely, absolutely.
So I think we'll stop with the questions now, and we'll ask a few more towards the end. So do just pop them in the questions box if you've got anything else you want to ask Seamus. So we'll move on from the questions just now.
Okay, so we're going to move on to step 4, which is your initial discussions with suppliers. So by now you get some sense of what you're looking for financially out of a system, and you have hopefully an idea of how much heat you use, and some information about your existing system. You're now armed to ready to have a discussion with your suppliers, and having as much of that information as possible ready for them really does help. But it's also important to to state as clearly as possible the other parts of the other requirements which aren't specifically related to the plant. So anything else about your business which is specific, how you use heat, have you got, whether you're a seasonal business which has got a very seasonal requirement, it's important that you give them as much information as possible. But all of that information you've got in the first two steps is really key to having a successful discussion with them. As Lindsay just suggested before, it's also worth speaking to people who've had biomass systems installed to find out which suppliers have get a good reports and a good reputation. And the Green Network for Business is an excellent resource for finding out some of that information. So once you've contacted the suppliers and you've got, hopefully you get proposals back from a number of them, and this is really the point where you narrow down what you want. So I'd have an initial it's often useful to have an initial discussion with suppliers to get some both ideas on how to design systems. Many of them are very experienced and can give you some ideas on how a system can be laid out and designed to meet your needs. But then if you can go away, compare from your results from different suppliers and narrow down exactly which type of system you're going to use, and use that also to probe further thoughts and any other requirements you've got for how during the system, when the system's going to be installed and when you're running it. And then it's important to think about, part of this is how you're going to maintain the system and how you're going to operate it. It's very easy to think about in your discussions and when you're deciding what system you want, about specifications of boilers, what size of boiler you're going to use, what fuel you're going to use. But it is really worth thinking about how you're going to run it week to week. And you can use suppliers, you can use maintenance contractors, for example, to operate the boilers on your behalf. It's worth doing that to have fully considered the implications of running a biomass boiler. They do need more work than oil boilers or gas boilers, and they can have very significant savings associated with them. But if you don't want to undertake any maintenance or fuel handling or anything like that, then you can quite often find a contractor who's willing to do it on your behalf. And finally, just to reiterate the point, speak to several suppliers, get as many viewpoints, as many prices and as many inputs as you possibly can. Speak to as many people who've got experience, and be informed, but try and keep an open mind about the options for how you can, what your options for your site. Just as on what I talked about there, this slide, reducing the risk of operations, the maintenance contractors are a really good way of reducing risk, and this can be as much an issue for internal sign-off as within your business as it is for the people who are actually having to do the maintenance. If your business is concerned by some of the risks associated with buying and operating a biomass system, you can also use the likes of energy supply companies to ESCO arrangements to have someone supply you with heat from plant that they own and operate. And so it does reduce your financial payback. It does mean that the system's less financially attractive, but there's a lot of contractors offering this, selling to businesses, and particularly where it's very critical to the business that the heat source operates. So again, we come back to perhaps process heating. Then having a contract in place where you've got some some means of recourse, some way of getting penalty clauses, for example, to cover you for costs, is a good way of reducing the risk to the business. And one of the most important things is to compare. So once you've got all of the proposals from all of your contractors, compare them as much as possible. Capital costs, operating costs, and get as much information as you can about repair and maintenance. And any discrepancies that there are between different suppliers, any contradictory information, make sure you ask them follow-up questions, and try and gain a full understanding of why suppliers have suggested certain systems to you or discounted or advised you against others. So we're going to go to our next poll now.
Yeah, this is our final poll, and it's really just, Seamus has obviously talked about all the things to consider when you're investigating biomass, but we just want to know what your main motivations are for considering biomass in the first place. So the options should be there on screen now, and option 1 is reduce running costs, option 2 to reduce carbon, option 3 reduce business exposure to fluctuations in fossil fuel prices, and option D, which is another motivation. So if you could just complete that on-screen poll now. Well, there's quite a few people selecting other. I'd love for you to pop your reasons in the chat box or into the questions box just to give us an insight into what those other motivations are. And then the other things that are being kind of mainly selected are reducing running costs and to reduce carbon. So I would have expected a few to select the reduce the exposure to fossil fuels, because obviously that's something that, you know, as time goes on it's going to be more and more relevant. But
it's something that's relevant.
I'll just share those results. Sorry, Seamus.
It's quite interesting that, as you say, we've got so many people in other. We've also got quite a number of people who are primarily interested in reducing carbon. Biomass is very attractive from a carbon perspective because it is either considered to be carbon neutral or very close to carbon neutral, and so compared to other renewable heat technologies, it tends to perform very well on a carbon from a carbon perspective.
Excellent. Yeah, and if you have selected other, please do pop your reasons in the question box or in the chat box so that we can have some insight into what those might be. So I'll just hand the slides back over to Seamus now.
So, thank you very much. So we're on step 6. So, but at this point, once you've spoken to several suppliers, you've got some information, you really know what system you're going to be looking for. It's important that you specify exactly what you want and obtain a detailed specification, obtain a detailed quotation for the system. Now, for larger systems, this can mean asking for someone to prepare a specification for you. Usually, this would be like a consultant engineer to detail out the design of your system. For other people, for smaller systems, it may be just you gathering together everything that you've learned and specifying as much as possible of what you know you need your system to do. And this can be your heat requirements, operational requirements, day-to-day operational requirements of the boiler, but also so things that will affect your business as they're installing, downtime for during the installation process. Consider as much of that as possible and specify it to the installer. Make sure that they're aware of what you need. Boiler specifications, if you have identified fuel sources, for example, if you know you've got fuel suppliers lined up and you know that you need, I'll take an example, a wood chip boiler to burn up to 35% moisture content, you need to make sure that the boiler is going to be capable of doing that. So that can come from fuel type you need to specify, but if there's anything you know about the specification of the boiler, it's important that that's clearly stated on the quote, so that when the suppliers are quoting you for something, that it's going to provide that for you. Fuel type's clearly important. The control system is as well. How a biomass boiler is controlled has a very big impact on how efficient it is. And if you've got an existing system in place, do you want to retain your existing control functionality, or do you need to upgrade the controls? Is this an opportunity to make some changes to other parts of the system as well? It's important you've thought about it. Fuel store capacity can again partly come from your information from suppliers if they've got minimum delivery amounts, but also worth considering where your site is. Are you likely to have a period of time during winter when you can't get hold of fuel supplies? How long do you need to have fuel supply for as a backup? And also, how much notice do you need to give to suppliers? It's important that you've got enough fuel in there that you can give the suppliers at least a few days notice of them needing to come to site. And having a sufficiently big fuel store really makes a difference in terms of what it's like to operate the system. The flue specification is very important. It's not likely to be something that most people will be able to specify themselves, but if you have had any investigations done, if you know for certain anything about the flue requirements, and this might be something that's been specified to you from discussions with your planning department, from an environmental health officer, if there's abatement measures or any requirements that you have to meet for an air quality management area, an AQMA, just make sure that all of that is specified, so that there's not additional costs encountered at a much later stage. And then timing, that can be both in terms of, the most important thing is, from your business, when do you need the system to be installed? When do you need it to be online? How does that fit into your business planning as well? If you've got a narrow window for this to come online, you've got to make sure that that's done. And then anything else that's specific about your site, which won't necessarily be apparent to other contractors, the likes of health and safety, if you have explosive environment requirements, for example, anything like that, or Disclosure Scotland. So then moving on to step 7, once you've got your quotes from your suppliers, it's about reviewing them, and it's very important that you check that everything you've specified is either provided for, or if they have put an exclusion into the quote, that you understand it and have costed it. So particularly for long and complicated quote documents, anything that's excluded or anything that they have assumed, make sure you understand what those are and you consider what the cost implications are for you. And then anything else which is important to the business, anything which is from the criteria you've set yourself at an early stage. So once you know, at step 8, we're looking to finalise your internal business case. So once you've reviewed your quotes and you've narrowed down which supplier you're going to use, it's really important that you have an accurate picture of how the system's going to perform for you financially. Hopefully you'll have, it may be that you've done an early stage, an outline of what your options are, narrowing down to biomass or narrowing down to certain fuel types, what the financial performance is going to be. But once you know what the capital cost is, once you know what the maintenance requirements are and the maintenance cost and your fuel costs, you can really finalise that internal business case so that you know exactly how it's going to perform with the best, perform financially with the best possible information. And before you go ahead and place the order, you really have to make sure you've got planning permission for anything or any other permissions that you're likely to require. This might be, there may be other permissions required as a result of your application for planning, air quality, for example. But it's important that anything that you require permission for, land access requirements, if you've got to cross someone else's land, you do all that before you commit to spending the money. And then at this point, hopefully you're ready to place your order. And so just for a check for yourself, make sure you understand exactly what you're going to get. Make sure you've got all your permissions and make sure that you understand anything that's required of you for the before you can move before your contractor can do it. If there's any enabling works that a builder needs to do to build a plant room or anything like that, be sure you understand them and you've got them planned in yourself, and you fully understand what the costs are. That can also be anything which, like electricity supplies, networking if you're going to have, or controls, and that should really come from the exclusions in the quote. So we're going to finish off looking at problems to avoid and how to run a successful system. And these can be problems to avoid. These are the issues that many people encounter with biomass systems and are unfortunate but avoidable. Oversizing biomass boilers leads to problems, and it's important that when the system is sized, the biomass boiler the whole system is designed so that the boiler can run for as long as possible. A way of thinking about this is if you've got a combi boiler in your house, they can turn on and off quite frequently as your load ramps up and down. But a biomass boiler can't do that and run efficiently. It needs to turn on and run for probably a period of hours at one time. And so the way that this is done is using a buffer tank or a thermal store. And so oversizing a biomass boiler makes it much more difficult for the boiler to be able to do that. And the way that people encounter that problem is by not considering an installer not considering the load that a system has. Biomass boilers have many advantages over other renewable technologies. The temperatures they produce are similar to oil and gas, for example. They're able to meet high temperatures unlike heat pumps, and that means many people can think that it's just a case of connecting up a biomass boiler in place of an oil boiler. But if you also need to consider what the load on the system is and how that's going to fluctuate. So the information we've got at step 1 about how much energy you use, about your peak requirements, about the different uses of heat on site are going to be really important for your installer to build up that picture. But make sure when you're discussing things with installers that that's something that it's clear to you that they've got an understanding of. And finally, the control of backup boilers is important because they can rob load and effectively steal some of the heat load from the biomass boilers. If you need to produce a certain amount of heat to get your RHI income, or if you want to produce a certain amount of your load, if your business case is based on you supplying, say, 70% of your load from a biomass boiler and 30% from another backup, it's important that the backup boiler doesn't run for more than that, and it's down to the control system to be set up correctly. I mentioned fuel problems already, but it's very important that you get good quality fuel, but consistent fuel quality. Moist wood chip can be burned if the boiler specification is up to it, but you need to make sure that, as we talked about before, it aligns with the specification. But one of the most important things is the consistency. If the quality of fuel changes, then people encounter a lot of problems. So once you're running your system, one of the most useful things as a commercial operator is if you're claiming non-domestic RHI, you will be required to install a heat meter, and you can use that to your advantage. There's a lot of information available from heat meters which you can use to understand how your system's performing, so you can compare how much fuel you've had delivered to how much heat you've got out and calculate how efficient the system is. Some heat meters, for example, you can do data logging, so you can log how your heat load's changing, and that can be used to tell how the control system's operating. So the heat meters are really useful, and if you've spent the money on having one installed so that you can claim the RHI, it's really important that you get as much information out of it as possible to make sure the rest of the system's performing. And as I mentioned before about backup, a key way of doing that is if you're expecting your oil or gas consumption to drop significantly, if you've installed a biomass boiler alongside it, make sure that usage is dropping as much as you expected it to, so that you don't want to get to the end of several months or a year down the line and discover that most of your requirements actually have been done by the oil boiler and the biomass has done relatively little. And then finally, it's your equipment. Someone asked the question earlier on about the longevity of the system. It's maintenance maintenance is key to a system running for a long time and running efficiently. And if you're employing maintenance contractors, it is important that you check that they are doing the work that's required of them. And so don't simply assume that they're doing it. It's too important, and if you find that annual servicing, for example, hasn't been carried out, it's been missed, or also have a look at, it's worth finding out for those key pieces how much time it's likely to take. A simple check can be how much time it is on site. The boiler needs to be cool before you clean it out, for example. Did they turn up on site and the boiler was hot when they arrived and they were there for an hour and a half? And if so, they're not going to have been able to do a full service. Having a bit of an understanding of what they need to do will be really important to make sure that they're actually doing it, and that's going to be key to the system working well 10 years, 15 years, 20 years after it's installed, rather than having a problem after the end of the first few years. So hopefully that's been useful. I'm going to hand you back to Lindsay now.
Yeah, so I just really want to highlight to everybody that we offer one-to-one support for Scottish organisations. Now, Seamus has obviously gone through quite a clear step-by-step guide for you to specify and install a biomass system. But if there's any issues that you still feel that you would like some further support with, then don't hesitate to get in touch with us, and it may be a case of having a quick telephone conversation with a specialist or Seamus himself, or you might have something that needs a little bit more in depth and it would be a visit to your site. But yeah, definitely just be aware that we offer that one-to-one support, and to get in touch and make sure you use that. Now we'll just take a few more questions before we wrap up the session today. We've got some more that have come in, which is excellent. Somebody's asking, can I reuse the flue from my old boiler?
It's a good question actually. The flue, it's really important that the flue is sized specifically for the biomass boiler, and it's quite a specialised process designing flues in general, but particularly designing biomass flues. And so it's unlikely to be the case that an existing flue from an oil or gas boiler it's very unlikely that's going to be possible. But for every site, it's important that the flow requirements are checked. The biomass boiler will have a requirement for what's referred to as draft, what the pressure pressure generated by the flue, and so it's important that the flue is performing correctly, and it's unlikely unless it's replacement of a very similar type of plant, a very similar boiler.
Okay.
Probably not.
Someone saying you mentioned that replacing electric boilers has the best payback.
Yep.
And they said, does this include the cost of installing a wet system for the heat distribution?
It's a good question. That depends very much on the site. From a fuel perspective, the cost of electricity is much higher than natural gas tends to be, or even fuel oil. But it will likely add capital, so it comes back to the balance between what's your capital expenditure to install the system and what's the operational costs over the long term. So the operational costs are likely, you're likely to have, you will have much higher savings than if you were using gas, but the capital cost is a bit higher, and how much higher depends upon the building. So installing radiator systems can be relatively low cost, and that's something that's quite commonly done. And can still have very good payback. It's frequently the case that simply installing a radiator system, if you've got a more complicated building like an office that need air handling, or if it's something else, then it can add quite a bit of capital. So it is site specific, but it generally tends to be the case for standard space heating, perhaps hot water requirements, that even taking into account additional capital costs, they tend to be very attractive.
Okay. Somebody is asking that if they're thinking of installing a biomass boiler in their office to replace an LPG boiler which has failed, do they need to make any changes to the system before the biomass boiler can be installed?
So do they need to make any changes to their existing system? It's a good question. It comes back to the point that we just talked about in terms of the electricity. It's important that the biomass boiler, as we mentioned, can run for a long period of time at between 30% and 100% of its output. And if you have likes of an office where it needs quite a lot of heat in the morning to bring the office up to temperature, and then everyone comes into the office and turns the computers on and the load drops quite significantly, buildings like that, the load can change very quickly, and it's important that the system's designed in such a way that it's got enough buffer capacity or enough thermal storage capacity to allow those rapid changes in demand without affecting the efficiency of the boiler. So it's often that more often than not, the actual heat distribution system from an existing boiler can be retained, but it might have an implication on the size of buffer tank that's needed.
Okay. So can they keep their existing oil boiler as a backup?
Yes, and it's very common to use an oil boiler or a gas boiler to meet the peak load, and have a smaller biomass boiler effectively to supply the base load. So for 85–90% of your heating requirement throughout the year, the biomass boiler is big enough and can provide that heat requirement in combination with the buffer tank. But then during the real peaks in demand, the backup boiler can come in. Likewise, if you're and so you can retain it in that capacity. It's important to think about the longevity of that system as well, though. If you're trying to design a system so that the biomass will be capable of doing it on its own, if the boiler is likely to fail after a few years, then you've got to design the system so that the biomass can be capable of doing it on its own. So you can do it, but again, you need to think about the lifetime of the system, and are you going to replace that boiler when it needs to be replaced, or are you going to expect the biomass to do it alone?
Okay. And we've probably got time for just one more question, and someone's asking that their office building has an old coal store, and would this be okay to store wood pellets?
You can use, the old coal stores can be quite good for storing fuel. The limitation is wood pellets particularly, the fuel store needs to be very dry. It's important that all fuel stores are, and so there's usually work required to waterproof the coal stores, for example. So a lot of older buildings would have had coal boilers previously, and they can be very suitable for biomass, and there's often, if the space hasn't been reallocated, somewhere to put it, so that can work very well. But they have to get a specialist to look at the old coal store and check what's going to be required. It depends very much on where the boiler is going to be located as well. So the answer is it's possible that it could be useful, and it's something that quite a lot of buildings have, but get someone who's specialised in it to look at. Okay.
And maybe just squeeze in one last question. Is someone saying, is biomass more suited to a 50°C circuit?
It should be able to. You can get biomass boilers which operate for up to medium temperature, high temperature hot water systems. So the answer is, if you've got a 50°C circuit, the biomass boiler could provide for that. It's not necessarily the case that it doesn't need it. So biomass boilers can work at 70 or 80 degrees very commonly, even on low temperature hot water. I referred to low temperature hot water. It doesn't specifically mean that it needs to be like a heat pump 50 degrees. They tend to have, biomass boilers tend to work better with larger temperature differences. Many of the manufacturers will specify heating systems with, getting a bit into engineering talk here, but big temperature differences in flow and return. And so so for example, a 20-degree temperature difference, if you've got a system which is designed for a low flow temperature, so for example underfloor heating, it can sometimes be the case that they're designed to run at relatively low temperature differences. And so again, it's something that can be managed by the design of the system. It needs a bit of thought. But one of the real advantages of biomass systems over many of other heat pumps, for example, is they can be made to work for most heating systems.
Okay. Fantastic. So just like to finish by highlighting again how you can get in touch with us, through the website, through our helpline number, which is on screen now, or you can tweet us or email us via the website. So do utilise our services and contact us if you need any further support. So I'd just really like to thank Seamus for his time. Thank you everyone for logging in. I think we've got some really clear steps to designing and installing a successful biomass, so hopefully it's been a great help to everybody that's joined today. So also check out the events on the website and see what's coming up and sign up, and we hope to see you there. Take care everyone, talk to you soon, bye bye.